Chapter 13 opens up with a great core case study about the Colorado River, a river that we have changed dramatically over time. So definitely read this and keep these things in mind as we look at water resources. All right, so first section, will we have enough usable water? So water is a big issue. It's a global health issue because of diseases that can be transmitted through water. It's an economic issue because we pay for it. It's a issue for women and children because they often spend massive amounts of time collecting water. It's a national and global security issue. Water crosses borders. It doesn't care which country it's in. And of course, it's an environmental issue because of the ecological effects of not enough water or too much water. A very, very, very small percentage of Earth's water is actually readily available. Most of the fresh water on Earth is trapped in ice caps and glaciers. So the water that's in groundwater, lakes, rivers, streams is the stuff we can actually easily get. We have a couple of vocab terms. So when we're talking about groundwater, the zone of saturation is the area in the soil where all of those pore spaces in the soil are full of water. The zone above that is called the zone of aeration. And the top of the zone of saturation is known as the water table. The water table can change. When you get lots of rain, the water table goes up. And when you get less rain or you withdraw a lot of the groundwater, the water table goes down. When we talk about groundwater, oftentimes talk about aquifers. Think of these as like slow-moving underground rivers almost, where water is going through porous spaces in rocks. They do slowly recharge, usually by precipitation. This can be affected by changing the surfaces. So when we increase impervious surfaces, paving, concrete, cement, things that water cannot permeate through, cannot infiltrate into the ground, that increases the amount of runoff and you get less recharge of those aquifers. Speaking of runoff, when we talk about watersheds or drainage basins, about 1/3 of the runoff that goes into surface water, into rivers and streams, is considered reliable runoff. About 2/3 of the water gets lost in like heavy rain events, flooding, things like that. And then the water that infiltrates into the ground goes into the groundwater. When we look at United States water use, it's a little different from worldwide water use. So worldwide, about 70% of water is used for agriculture, 20% for industry, and 10% for residential use. In the United States, about 41% is used for electric power plants, primarily in the eastern part of the United States. 37% is used for irrigation. That goes up a lot when you get into the western United States. 13% for public water supplies, and then 9% for industry and livestock. Of our residential use, about over a quarter of our water is used for flushing toilets. We'll talk more about that later on. And then washing clothes, showers, faucets, leaks. So we're using roughly in the United States about 69 gallons per day. The poorest people in the world use about 5 gallons per day. That's the water we directly use. Then we also have our virtual water, or indirect water use. So we have some examples here in this science focus box. So the water, we kind of trade water with other countries through an indirect use. So if your jeans were made in Bangladesh, you're using water from Bangladesh, essentially. All right, and then there's a map showing where there are potentially shortages of water in the United States, focusing on the western parts of the U.S. And going back to our core case study with the Colorado River, some problems with the Colorado River is that it flows through very dry lands. It's a relatively modest flow, given the size of the water. There were pacts that were made between the United States and Mexico, which basically guarantees more water for people than is actually available and doesn't guarantee any water for wildlife. The Colorado River usually doesn't even reach the Gulf of California in a lot of years. It's because so much of the water has been withdrawn. And then it can be polluted as well. And we'll talk more about water pollution in chapter 20. All right, so in terms of water shortages worldwide, figure 13.6 shows you where there are areas that are under a lot of high stress in terms of water. hopefully you've been following in the news, we're seeing this happening in Cape Town, South Africa. They have drastically reduced the amount of water that they're using in hopes to avert day zero. This is hoping that the usual increase of water that happens in our summertime, their winter, will occur. All right, so we need more water, so how can we get it? So we can extract groundwater. You can see some trade-offs on page 325 about withdrawing groundwater. About 1/3 of water withdrawal in the United States comes from groundwater, and about half of the world's drinking water. There are disadvantages, including when you withdraw groundwater from the coast, you can get saltwater intrusion. And we can see how withdrawing groundwater has had effects on very arid areas such as the desert in Saudi Arabia. And you can see all of these little green circles right down here. Those are due to center pivot irrigation systems. So we have depleted our aquifers in the United States. The largest aquifer in the U.S. is the Ogallala Aquifer, which is underneath most of that large red area in the map. And we are withdrawing water faster than it can recharge. And this can have a lot of effects like subsidence and other things. So we can see some potential solutions, both prevention and control, for groundwater depletion. All right, could also build dams. So we have a great image here on page 328 showing advantages and disadvantages of dams. Again, you could look at the Colorado River for good examples, a lot of these issues. Oh, part 2 is interrupted by my son. So we're talking about dams. There are good things, there are bad things. But we can see that a lot of our subsidies from the government that involve water, particularly for irrigation and transfer, again, think about the Colorado River, everything going on there, has allowed farmers to grow really water-intensive crops in semi-arid regions. And that gets us into 13.4, looking at water transfer. So when we think about the Southwest and California, which is where a lot of our crops come from, there are tons of like aqueducts, something we don't see in Massachusetts, that carry fresh water to relatively dry areas. So you can see this map, figure 1316, showing these aqueducts transporting water. And then for kind of best example of what happens when you transfer water a little bit too much, the Aral Sea. It's a classic example. There are connections to a lot of topics that we talk about in this course. We can also, so 97% of our Earth's water is salt water. Can we remove the salt from that water? That's desalination, which can happen through distillation or reverse osmosis. As you can see right here from this headline, it's costly, it kills marine organisms, and it produces a really briny, salty wastewater. Right now, it provides about 1% of fresh water supply in the world. That is expected to increase. Some places like Israel gets 55% of its domestic water use from desalination, and the cost is about 1/3 of what it was in the 1990s. So this is something that we might see happening more and more, but it does have its drawbacks. All right, so can we actually reduce the amount of water we use and use it more sustainably? Yes, absolutely. A lot of it comes back to those government subsidies, which artificially lower the cost of water. So some solutions to that could be subsidies to encourage water efficiency, or some places, because water is relatively cheap, you could put a really low fee that covers the basic needs that everyone needs for water, and then once you go above that, you have to spend a much higher amount per gallon, for example. We can also use different irrigation methods. So flood irrigation, which you can see right here, a gravity flow, is really cheap but has very high evaporation rates. Center pivot irrigation, which is the one that gives us all those little green circles that we could see in a few earlier images, is much better. And then the best is drip irrigation or micro irrigation. Sometimes the pipes are above the ground, sometimes they're even below ground, which is super efficient. But as you can imagine, much more expensive. Okay. So we can reduce some irrigation wastewater. And part 3, because my son is home. This is from doing things on a snow day. So we can reduce the water we use for irrigation. Some nice solutions right up here, like irrigating with treated wastewater, something we don't do too much of around here. We also have some great ideas for how we can reduce water waste overall. Keep in mind that because of all those virtual ways we use water, the indirect ways, by reducing your purchasing, your energy use, your meat consumption, you can actually reduce your indirect water use as well. And something that boggles my mind whenever I think about it, we use perfectly good drinking water to flush toilets. So that's something that could easily be done using gray water, which is water that goes from like your sink, etc. There are even these little sinks that you can actually mount on your toilet tank so you can wash your hands, and then the water that you use to wash your hands then fills the tank to flush the toilet. And I'm trying to convince my husband we should get one of those because it would be pretty amazing. You can also do things like plant rain gardens or vegetation in your yard that does not require a lot of water. This is especially important in areas that are very arid. So there are things we can do, and we can see on page 339, again, some solutions. Do not deplete aquifers. It's kind of a big thing. How do we not deplete aquifers? We reduce our water waste. And then things like, what can you do? Definitely read through those. Try to pick at least 3 that you could easily do. If you don't turn off the sink when you brush your teeth, that's the first place to start. But go above and beyond that. You can do better. All right, so been talking about all these water shortages, but then we also have flooding, kind of our opposite problem. Too much water. A lot of people live in floodplains. Why do they settle in floodplains? You get fertile soil. There's plenty of water for irrigation. Rivers are a great source for transportation and recreation. And all of this flat land that we find in floodplains, it's really good for growing crops and development, building, etc. So you have lots of people in these floodplains, which then puts them at greater risk of losing their lives and property damage, and being threatened by water pollution, even from floods. We make flooding a lot worse when we remove vegetation. Okay, so this could be just small vegetation, but also deforestation and filling in wetlands, or draining wetlands. And we see how this was a major problem in like New Orleans with Hurricane Katrina. This case study on flooding in Bangladesh, please read it and look at all of the different issues that have been happening there and why. It continues every year. It seems like thousands of people die in Bangladesh from flooding. So we can reduce flood damage as well. And then the book throws in this, the precautionary principle. So we can think about where we choose to live. And some people don't really have a choice, because if they are very poor, for example, they might just have to live where there's available housing. But a lot of our fanciest houses are built in areas that are prone to flooding. So why do we do that? All right, and that was chapter 13 in 3 parts. Sorry, guys.